This video will talk through the worked out solutions to the 7D and 7E review packet, or review worksheet. On the front, all of the equations tell you how you are supposed to solve. On the back, we'll see that we can use any method. So it's important that we start thinking through when would I use which method. So on the front, it tells us to use a quadratic formula. I know I only use the quadratic formula if the equation's in standard form. So looking at this, before I can use the quadratic formula, I have to get the equation in standard form or set equal to 0. So I'm going to move everything to the left-hand side, so I will subtract x squared. When I do that, I'm going to put it underneath the 4x squared because I know that those are like terms and they'll go together. I still have the 5x on the right-hand side, so I'm going to subtract 5x, and I'm going to put that right in the middle so that I have the x squared and then the x and then the constant term. So I have 3x squared minus 5x minus 20 equals 0. Now that it's in standard form, I can identify a, b, and c and solve the equation. Let's zoom in a little bit for you. Alright, so here I know that the a is the coefficient of x squared, so that would be 3. B is the coefficient of x, so that would be negative 5. And c is the coefficient, or sorry, c is the constant term, negative 20. So if it's asking me to use a quadratic formula, I know that that would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I simplify that, the opposite of negative 5 is a positive 5 plus or minus the square root of negative 5 squared is a positive 25. A negative times a negative will be a positive. And then when I look at this, let's see, I know that 3 times 20 is 60. 60 times 4 is 240. All divided by 6. I still have to simplify the discriminant, or in other words, what's underneath the radical, or the radicand. So that would be 265. And when I do that, I have to then try, that's all over 6. And I have to try and simplify the square root of 265 if I can. I always got to check that. To the side, I'm going to make a factor tree, 265. Because it ends in a 5, I know it's divisible by 5. I'm going to use my calculator to figure out 265 divided by 5. What does that equal? That would be 53. And I believe 53 is a prime number, so I don't have to worry about simplifying. That is my final answer. That's my exact solution. 5 plus or minus the square root of 265 all over 6. It also wants the decimal approximation. Well, I can simplify square root of 256 to about 16.28. So that would be about 5 plus or minus 16.28 all over 6. And from there, I have to break it apart into two equations. X is either 5 plus 16.28 all over 6, or x is 5 minus 16.28 all over 6. And so to the side, if I do my work here, 5 plus 16.28, that would be, that should be approximately, right, because we rounded. So x is approximately 21.28 divided by 6. Or, so if we added 5 and divided by 6, we get 3.55. And over here, x would be approximately negative 11.28 divided by 6. So if we do the square root of 265 again, 16.28. I then multiply that by a negative 1 to get a negative. Do 5 plus that answer. It gives me negative 11.288 divided by 6. We get x is approximately negative 1.88. So x is approximately 3.55, comma, negative 1.88. All right. That was the quadratic formula. And again, the reason we used that was because it was in standard form. Now, sometimes it's easier to factor when an equation is in standard form, but this time, this will not be easily factored, so we use the quadratic formula. Switch it on to number 2. This again says to use the quadratic formula, and it wants to answer in simplified radical form. That means it's not a decimal. So when it says simplified radical form, I don't want decimals. You're going to see a radical, a square root in your answer. Again, it's not set equal to 0, so I do need to get it set equal to 0 first. I could move the 50x over, or I could move the 5x squared and negative 75. However, because it's only one term that I have to move over here, I'm going to go ahead and do that. So that's 5x squared minus 50x minus 75 equals 0. And again, if I'm using the quadratic formula, I need to identify a, b, and c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. And there we go. So now, using the quadratic formula, x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. As I simplify this, the opposite of negative 50 is a positive 50, plus or minus the square root of 50 squared, or negative 50 squared. It doesn't matter because the negative times the negative is a positive. It's 2,500. A negative times a positive times a negative will be a positive. And if I want, I can just punch this in my calculator. 4 times 5 times 75 is 1,500 all over 10. All right, we're getting closer. We still have to simplify that radicand. 2,500 plus 1,500 would be 4,000 all over 10. Now, see if we can simplify this. Square root of 4,000. Oh, it's a decimal. It's an irrational number. So we need simplified radical form. Now let's think about this. If I'm going to do a factor tree, it's going to take a little while, but we can do it. I know that would be 4 times 1,000. Break that apart. That's 2 times 2, 1,000. We do 100 times 10. 100 would be 10 times 10, 5 times 2, 5 times 2, 5 times 2. We've got a lot of prime factors here. Alright, so if I'm simplifying that, that's the square root of 2 times 2 times, we got 3 more 2's, 1, 2, 3. And then we got 1, 2, 3, 5's. 1, 2, 3. We have to group these into perfect squares, group, and then group here. So we're going to have the square root of, I'll write my perfect squares first. And then we got these leftovers. Well, the square root of 2 squared is 2, square root of 2 squared is 2, square root of 5 squared is 5. Square root of 2, that's irrational, so that's going to stay under the radical, and same with the 5. So now 2 times 2 is 4, 4 times 5 is 20, root 10. So now we have x is equal to 50 plus or minus 20 times the square root of 10 all over 10. When we get to this point, we have to see, can we simplify this? The only way to simplify is if all of the non-radicals are divisible by the denominator. So yeah, these guys are all divisible by the same thing. They're all divisible by 10. So we have x equals 50 divided by 10 is 5, plus or minus 20 divided by 10 is 2. And this stays the square root of 10 because that's under the radical. Excuse me, and that's our final answer in simplified radical form. Alright, switching on to the next one. It says, solve the equation by factoring and then using the zero product property. Well, before we can do this, because it's an x squared and x, we got to get it set equal to 0. Got to get it in standard form. So I'm going to subtract 8 from both sides. Now I have 5x squared minus 18x minus 8 equals 0. Now, if I was given a choice, I could use the quadratic formula if I wanted to, but this is telling me specifically I need to solve by factoring. So, because the leading coefficient is not 1, I'm going to have to use the area model or the box method or factor by grouping. They're all one and the same. So to do factor by grouping, I need two things that multiply to be a times c. So 5 times negative 8 is a negative 40. And then my b term is negative 18. So I need two numbers that multiply to be negative 40 and add to be negative 18. As I sit here and think, if to multiply to be negative, I know one needs to be positive, one needs to be negative. Because they're going to add to be negative, I know that the larger number is negative. I'm going to do negative 20 and 2. Those two numbers multiply to be negative 20 and add to be negative 18. So, in factor by grouping, I put my 5x squared here, my negative 8 down here. That middle term, we're going to break it apart into negative 20x and a positive 2x. Now, we could have interchanged where these go. It doesn't matter. We'll still get the same thing. Now, I cover the bottom run up, and I look 5x squared and 2x. The greatest common factor is just a plain old x. X times 5x is 5x squared. X times a positive 2 is a positive 2x. Down here, the GCF, because the leading coefficient is negative, I'm going to factor out a negative common factor. These are both divisible by 4. Negative 4 times 5x is a negative 20x. Negative 4 times 2 is a negative 8. So it checks out. So now I take these two as my factors and I rewrite this equation. 5x plus 2 times x minus 4 equals 0. Can't forget that equals 0. Now, we factored to get something that was in standard form into intercept form, and then we know once it's in intercept form, we solve using the zero product property, where we set each factor equal to 0. And so as I do that, I can come up with my solutions over here. If I add 4 to both sides, I get x equals 4. On this one, if I subtract 2 and then divide by 5, I'll get x equals a negative 2/5. And here are my two solutions. So that was factoring and then using the zero product property. If I scooch over to the right for number 4, it says solve using the square root method or taking the square root. Another way to say this is just using inverse operations. And that happens if we are in vertex form. Okay, seeing one thing being squared. So I have to isolate what's being squared. I know that this whole thing right now is being squared, so I'm going to subtract 5 from both sides. When I do that, I get x minus 4 in parentheses squared is equal to 25. And now that I've isolated what's being squared, I can undo the squaring by square rooting. And the square rooting undoes the square rooting or squaring, so I'm left with x minus 4 equals plus or minus 5. Remember, as soon as I take the square root, I need a plus or minus, because 5 squared is 25, and so is negative 5 squared. Well, now I have two possibilities. X minus 4 equals 5, and x minus 4 equals negative 5. So I add 4 to both sides, I get x equals 9. Add 4 to both sides, and this time I get x equals negative 1. Alright, so on the front we were told how we needed to solve. On the back, we're going to be given a choice. So if we flip to the back, excuse me, the directions just say solve the equation. I still recognize that when it says solve, that means my answer looks like x equals or y equals or whatever variable I'm solving for equals. Alright, so this one, I see an x squared and an x. That tells me that this is in standard form. It's set equal to 0 already, so I can try and start solving. Now we have multiple ways to solve in standard form. We have both quadratic formula and by factoring. Because factoring can often be faster, I'm going to try solving by factoring first. I know my first step in factoring is to factor out a greatest common factor, and that GCF is 2. So I factor out a 2. 2 times x squared plus 14x plus 45 equals 0. And now that the leading coefficient of this quadratic expression is 1, I know that if, excuse me, if I can find the product sum, then this will be a very fast one. So I'm ignoring that 2 and I'm just saying, okay, I need two things that multiply to be a times c, or 45, and add to be b, or 14. As I think through these numbers, I know that 9 times 5 is 45, and when I add them together, I get 14. Now, I could do the box, but because that leading coefficient is 1, I don't have to do the box. I can just carry down my GCF, and this will become x plus 9, x plus 5 equals 0. And now, I can solve using the zero product property. I can try and set each factor equal to 0, but when I set 2 equal to 0, I can't solve for x, so I don't really have to worry about that. But over here, I can set both of these guys equal to 0 and get x equals negative 9 and x equals negative 5. Alright, there are other ways to solve this problem, so I'm going to do a little squiggly line here and then below here show you how else you could have done it. If you wanted to, if you wanted to use the area model to factor, you could have done your x squared 45 and then do your 9x and 5x. Your GCF here is x, so x times x is x squared and x times 5 is 5x. Over here, the GCF is 9. If I check it, 9 times x is 9x, 9 times 5 is 45. And I still get this x plus 5 times x plus 9. And then I'd have to carry down that 2, of course. And I could continue from there. Okay? I could have also done the quadratic formula if it's in standard form. And if I did that, I would do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 28 plus or minus. For the sake of time, I would just punch this in my calculator. Parentheses 28 squared minus 4 times 2 times 90, and I get 64. So plus or minus the square root of 64 all over 4. So that's negative 28 plus or minus 8 all over 4, and this is when I break it into two equations. Negative 28 plus 8 divided by 4, negative 28 minus 8 divided by 4. Well, negative 28 plus 8 would be a negative 20. Negative 20 divided by 4 is a negative 5. Over here, negative 28 minus 8 is a negative 36. Negative 36 divided by 4 is a negative 9. So I still get the same answers, but if I can factor, it is often faster. Switching over to B. Over here, because I see an x squared and an x, I recognize that this is standard form, but I have to get it set equal to 0 first. So I'm going to add 20x to both sides. Because these are not like terms, I cannot combine them, so it just looks like this. Whenever it's in standard form, my first attempt is to factor, and when I look at this, I have to factor out the GCF first. Well, the GCF, I noticed that the GCF of 12 and 20, I believe, is 4. But then I have an x squared and an x, and the GCF there would be x. So if I factor out a 4x, I'm left with 3x plus 5 equals 0. And when I look inside the parentheses, because this is a linear factor, I cannot factor it any further. So now it's factored, set equal to 0. I can use a zero product property where I set each factor equal to 0 and solve. If I divide by 4, I get x equals 0 as one solution. Subtract 5 from both sides, divide by 3, and I get x equals negative 5/3. Now, you did not have to solve this way. You could have used a quadratic formula, but it would take a little bit more work. Let's see what it looks like if I use the quadratic formula. Again, I had it already solved, 12x squared plus 20x equals 0. In this case, a would be equal to 12, b would be equal to 20, and c would be equal to 0. So we would have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 20 plus or minus, well, this will be just, that's all 0, so square root of 20 squared, well, let's just say leave that as 20 squared, and you'll see why I'm doing that. Because square root of 20 squared is just 20. Remember inverse operations. So I have two possibilities, negative 20 plus 20 divided by 24, negative 20 minus 20 divided by negative 24. And if I simplify these, I'll see that 0 over 24 just 0, and this one is negative 40 over negative 24, which simplifies, excuse me, that's over a positive 24, simplifies to negative 5/3. So you could solve it either way, however, I think solving by factoring is much easier in this case. All right, scooching down here. Example C. When I look at this one, I see an x squared and an x. I gotta get my x's to the same, or x squareds to the same side, everyone to one side, 0 to the other. So I'm gonna add 9 to both sides, add 9. Those add to be 0, so I'm left with 7x squared plus 3x plus 9 equals 7x squared. I still gotta move that 7x squared to the other side, so subtract 7x squared. When I do that, these both add to be 0, so I have 3x plus 9 equals 0. Now this looks weird because my x squared term is gone, so when I look at this, this is no longer a quadratic equation. We don't have x squared, we just have one plain old x. This is a linear equation. So to solve linear equations, I just do inverse operations, and I get one solution, x equals negative 3. Alright, then finally moving on to D. I see an x squared and an x. I have to get the set equal to 0 before I start solving. So So I'm going to add 2 to both sides. 2x squared plus 5x minus 13 equals 0. Now, because it's in standard form, I'm going to try solving by factoring. The GCF of these three terms is 1, so that doesn't help me at all, but I can try and now do my product sum. So two things that multiply to be 2 times negative 13 or negative 26 and add to be 5. So as I'm thinking through this, I'm thinking, okay, no one needs to be positive, one needs to be negative. The only things I can think of are 2 times 13, because they add to be a positive, I'd have to be negative 2. That multiplies to be negative 26, but that adds to be positive 11, so that won't work. So I don't think I can factor this guy. If I can't factor it and it's in standard form, I use the quadratic formula. Identify what A, B, and C are, and then substitute in. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 5 plus or minus the square root of 25. Negative times a positive times a negative is a positive. I'm going to be honest, I don't do that super well in my head, so I'm going to punch that in the calculator real quick. 4 times 2 times 13 gives me 104 all over 4. So x equals negative 5 plus or minus the square root of would be 129 all over 4. Alright, so let's look back at the directions, because once I get to this point, what the directions say might determine what I do. It just says solve the equation, and whenever it doesn't give me directions on giving me a decimal approximation or not, I always give the exact answer, which means simplified radical form. So going back here, I have to try and simplify square root of 129. But when I do that, I don't think... Oh, you know what? I made a mistake. Uh-oh, back here, when I added 2, I forgot to put that here. That's really an 11. Let's see if that changes anything. Make that an 11. That's an 11. Oh, that is going to change something. That's not 104 then. 4 times 2 times 11 would be 88. Oops. Which makes this 113. Well, I still try and simplify this square root. Square root of 113, though, I know it can't be simplified. So my final answer is x equals negative 5 plus or minus the square root of 113 all over 4. And then I just leave my answer like that. No decimal approximation necessary because I didn't specify it. And I am all set.